Okay, so an intro to differential equations. We're going to split the variables. All things with a y are going to be on the left. All things with an x are going to be on the right. We're going to integrate both sides. We're going to solve for c, and we're going to solve for c using the point that we're given. And last but not least, we're going to plug in for C and solve the equation for y equals whatever. So this is like a real rough set of steps for you to solve a differential equation. Just take a second, jot it down, and then you can keep this beside you as we're trying to start to learn what we're doing. So I'll be quiet for a couple minutes to let you copy. Okay, so let's take a look at what a problem would look like. And it's like a 99% chance you see one of these somewhere in your free response on the AP exam. Will it appear in multiple choice? Maybe, but we're not really worried about that. This is definitely the free response that we're looking to tackle because it's a real good chance that they ask one of these as one of your 6 free responses. So we are trying to find the particular solution, and I know we don't know what that means yet, but we want to find the particular solution through the point 2, 3. Find the particular solution through the point 2, 3, and we are given that dy dx is equal to y squared over x minus 1. All right, so keep the blueprint beside you. What's the first part of the plan? We want to split the variables. Now, that includes dy dx. We can treat dy dx like it's a fraction, and we can split the pieces. So anything with a y is heading to the left. Anything with an x, we want it on the right. So the easiest way to do that is to think of this as a cross multiplication. So if you cross these, if the y squared's up and we move it to the left, it's going to be downstairs. And if I move the dx to the right, it's going to be on the upstairs. So if we switch the pieces around, this would give us 1 over y squared dy is equal to 1 over x minus 1 dx. So it's important to note that the dx dangling on the outside means the same thing as on the top. Okay. And then we want to integrate both sides. So we've got 2 integral symbols. So I'm going to pause there. And do we have any questions as to what's happened so far?
So you just cross multiplied?
Yeah, that's definitely one way of thinking of it. That's not wrong. You can cross multiply. I just think of it as whenever you have fraction equals fraction, anything that's upstairs, when I move it over, it's downstairs. Vice versa, anything that's downstairs, if you move it over, by move it over, I mean to the other side of the equation, it becomes upstairs, which is basically what you do when you cross multiply. Yeah, I just think of it as if I want this on the left, it's heading down. If I want this on the other side, it's heading up. And then as I moved these pieces, whenever I ran out of stuff on the top, you just put a 1.
Oh, okay. No, I see it. Got it. Okay,
Makes-
we're good.
Okay, cool. All right, now you want to evaluate both sides. So we're going to take a peek and say, do I know how to do this? Because we want to integrate it all together. So forget about this for right now. Let's look over here. What would we need to do to integrate this? Any ideas, thoughts? What are we doing?
Flip it
We
out.
should bring up the y squared.
Yeah, we're just bringing it up, right? So that's y to the negative second dy. We haven't integrated yet, but we're ready to now. Is equal to, all right, what's the plan over here?
We substituted.
Yeah, we need to do u substitution. So for this problem, we're gonna go off to the side and go u du dx. And then that's gonna be u is x minus 1. It's gonna make du 1 dx. It's gonna make dx du. So we've got all the pieces we need. Now we toss this in, and that's 1 over u du. And now I scan it from left to right and say, do I know how to integrate all of this? Is everything set up? The answer should be yes. So if we start to go now, you hit integrate, and this would be y to the negative 1 over negative 1 is equal to, what do we get here, guys? Integrate 1 over u du. What's it going to be?
Negative y to the negative 1/2 over. Oh, that's natural log of u. Sorry.
Yeah, there we go. Good, exactly. Natural log of the absolute value of u. We know how to plug that in though. Plus c. Okay, so something to note here when you are doing your integrations on both sides, we only use one letter c, and we use it on the right side. So technically it doesn't matter where you put it, but we're just going to use it on the right side is the setup, because whether you have 1 or 2, it's still just a constant. So to keep things simpler, they just use one of these letter C's, and it's going to be on the right. So to recap, we have integrated both sides, and we've got a C here. So the only thing I'm going to do here real quick is just clean this up, and I'm going to flip this downstairs. So if I do that, that's just going to be y on the bottom. It's really negative 1 over y is equal to the natural log of x minus 1 plus c. Okay, this equation, the one with the plus c in it, this is called the general solution. It's called the general solution. Okay. All right, so keep an eye on your blueprint. Your blueprint now says to solve for c using the point we were given. What was the point we were given? We were given
2 and 3.
2, 3. So off we go. We're going to plug in 2, 3. So that would be the natural log of 2 minus 1 plus c. Over here, that's just negative 1/3. So check it out. What do we get? Natural log of 2 minus 1. 2 minus 1 is 1. The natural log of 1 is 0. So that's just gone. And c is equal to negative 1/3. Part 4, or number 4. Plug in for c and solve the equation for y. So we're going to take what we just found. We're going to plug it in for c. So now if we do that off to the side, we've got negative 1 over y is equal to the natural log of x minus 1 plus c, but c is negative 1/3. Okay. All right. How do we solve this for y? What do you think? What should I get rid of first?
Oh, putting the x equal to 0.
Well, hang on, we just want to solve for y. So the first thing I'm going to do here is I'm going to get rid of the negative sign. So that's 1 over y is equal to, now I'm just going to say negative, and I'm just going to copy what I did. Okay. All right, last step. I want to solve for y. Think of this as this crazy thing over 1.
Mr. Baker, 1 over 3 shouldn't be like positive because.
Yeah, you can if you want, or you can just put the negative sign out in front of the thing and put brackets around it.
Got it.
Either way is the same. All right, now I want you guys to take about 60 seconds, and I'm not going to say anything. Take about 60 to 90 seconds, and I want you to figure out how to solve this for y, and then we will talk about it in about 90 seconds. Ready, go. All right, what do we think? Plan, idea, what are we doing? I want to solve for y. What do you think? How could we make that happen?
Could it be the natural log of y and then it would somehow cancel with the natural log on the other side?
That's a great idea that we actually are going to use in future problems, but it's not this one, but that's not a bad idea. So check it out. We want to solve for y. So all you have to do, there's a couple ways of thinking of this. Would it make sense to say that I just want to turn this fraction upside down?
Yeah.
Okay, so let's do that. And if I turn the left upside down, I should turn the right upside down. Now, that's just a clever way of saying I cross multiplied. Think about it. If I cross, I would have 1 times 1 is 1. So let's write what you get up here. We'll just call this the mess. So this would be 1 times 1 is 1 is equal to y times the mess. And I want to divide both sides by the mess to get y. So does that make sense that I would have 1 over the mess is equal to y? In other words, that's just an easier way of saying that is just to say, oh, if you flip the left, you can flip the right. Everybody good?
Yeah.
Okay, any questions?
Sorry if you said this before, but what is the exact purpose of doing this?
What is the purpose of doing this? So what you're doing still is this is just a process of integration. Look what we start with. We start with the derivative dy dx. And from the dy dx, what do we end up with? We're just ending up with y. So this is just like a crazy form of integration for something that's like above and beyond level difficulty. So you're still just going backwards. Like you have regular integration, you've got U substitution integration, and then you've got differential equation integration, which is just taking something even crazier with X's and Y's involved and figuring out a way to integrate that to go backwards. And eventually these will get applied to word problems as well.
Okay, thanks.
Mhm. All right, so let's try again. First time you try differential equations, it's just kind of feeling your way through it, and then we see how we can go from there. So let's try the following. Let's say dy, same directions, dy dx is equal to e to the y times 3x squared minus 6x. And we have the point 1, 0. So this direction would be find the particular solution using the point 1, 0. So you guys talk me through it. I'm not doing anything except telling you yeses and nos. So what's the first thing we ought to do?
Splitting up the y and x variables.
Okay, so what's it going to look like?
One over e to y. Yeah, 3, whatever that's in parentheses.
1 over e to the y. What's after 1 over e to the y?
Yeah, dy.
Equals?
Dx times 1 over 3x, 3x squared negative 6x.
Now, is this on the bottom or is this on the top? Did we move the x's?
No, that's on top.
So think of it like that, right? So even though it's not written as a fraction, if it's not written as a fraction, it's on the top, right? So the y got moved, that's on the bottom, but these didn't go anywhere. So what are we going to have over here? Try that one more time now.
Yeah, 3x squared negative 6x over dx.
Times dx. Because that's going to get multiplied over and it would also be on the top. Okay, so that's our result when you split the variables. What are we doing after we split the variables? Say that again, you're cutting out.
For e to the y, if you're moving it, if you're like flipping it down to the denominator, do you have to make the power negative? Like, why is it still positive?
We didn't flip it, we just cross multiplied. So if you were to move e to the y downstairs here, just like normal day, forget everything, you've got this as a fraction and you want to just bring it downstairs, yes, that's e to the negative y. But if I'm just physically cross multiplying, then that doesn't change the value of your exponents.
Mr. Baker, I'm still confused. E to the y is the coefficient of this, the stuff that's in the parentheses. So how come, like, you separate one and move it?
All right, so let's try this. All right, let's try something like that. Forget about these dy's and dx's. Let's just look at this, right? And I want to get everything with an A on the left and everything with a B on the right. So I'm saying that even though this isn't a fraction, we can fix that. Now it is. All right, so if I want to bring this A to the left, currently it's being multiplied, right? So if I'm going to undo this multiplication, I would need to physically divide by it, right? That's how I get rid of it. And if I divide by it there, I divide by it there, which just means I'm literally taking that object. Now I have A over A squared B. Still with me? And now if I want to get rid of that B, I'm going to multiply both sides by B. And it means I multiply both sides by b. So does that make sense how I was able to take that and move the pieces?
Yes, absolutely.
Okay, that is the same thing, just in a cleaner form. This is just the messy form. So all I'm doing is to get this over to here, I'm multiplying it by 1 over e to the y. That drags it over there. To get this piece over here, you're just multiplying and bringing it up. This is still a fraction just over 1. So does anybody have any questions on how we're splitting these variables? Because that's super important that you understand that. Okay, what are we doing next, guys? What's the next step?
We integrate both sides of the equation.
Cool. So we take a look and we say, do we understand how to do that? So on the right side, nice and easy, no problem. On the left side, what are we doing on the left side?
Should we bring e up to the top like e negative 1?
You can, that's not a bad idea. But the problem with that idea is if we did that, scratch paper, do we know how to integrate that, Taylor?
Well, no.
No, we don't. So it's not a bad idea, bring it upstairs, but that's not something that we know how to integrate. So what's the only other strategy we have? If it's not something, now that being said, I still don't hate that idea. So let's bring it upstairs. Makes it cleaner, it'll make it easier. All right, that said, we made it cleaner, no problem, but we still don't know how to integrate that. That's no good. It's in a better format. So what's our only choice? What's the only thing we can do if we are stuck when it comes to integration? We got to do what?
How
Use
about-
substitution.
Use substitution. But now, since it involves the letter y, instead of u du dx, it's u du dy. Same drill, just different letter. So we're going to let u be equal to negative y. Du would be negative 1. Instead of dx, it's going to be dy. So negative 1 dy. And then if I solve for dy, dy would be negative du. Okay. And now we want to go through and plug all this craziness in. And what's that going to give us? That's going to be e to the u du is equal to 3x squared minus 6x dx. Okay, I'll be quiet for about 60 seconds. Integrate both sides. The right side gets a plus c. Plug in for u when you're done, please. Okay, so integrate the left, e to the u goes e to the u. Plug our thing in, e to the negative y. Now, what did I do wrong, somebody? How come nobody yelled at me? Back up, back up, back up. What did I do wrong?
I was going to ask you the same.
Yes, yell at me when I screw up. I make mistakes too. There should be a negative sign out front. I forgot I didn't carry it down. The du had a negative sign in it. So just like you can pull a fraction out, you pull a negative out with it. So this is negative e to the negative y. Okay. Is equal to what we got on the other side. Add 1, that's 3x to the third over 3. So that's x to the third minus 6x squared over 2 is minus 3x squared plus c. Okay, any questions on that? We've integrated the left. We have integrated the right. We have a plus c. What do we do from there?
I have a question. Wouldn't you also do a plus C for the negative E?
It's not wrong if you did. It's just plus C is plus C. We don't know what it is. So they just consider one of them to be sufficient. I don't really, there's no way of proving that to you, but they're good with just one of them. So any textbook you read, anything on the internet you read, it's always just going to be the one on the right getting it in this case. All right, so this is called our general equation, our general solution. And we now want to figure out what C is equal to. So if we're going to do that, I need to plug in my points, and my point is 1, 0. So if we plug in 1, 0, see what we get. E to the 0 is 1, makes it -1. Gives us, oh boy, I'm getting tired. How about 1? Add 2 to the -1, and we would get C is equal to 1. Okay. Next, we want to take that and we plug it in. So now we've got -E to the -y is equal to x to the 3rd minus 3x squared plus 1. Okay, and we're trying to solve this out for y. So first thing we're going to do is I'm going to get rid of this negative sign. So you've got options. Last time you saw me just tack a negative sign in front of everything. That's cool. Or you can change the symbols if you want. We can call this -x to the 3rd plus 3x squared minus 1. If you wanted, you could have just kept everything the same, tossed the thing out front. It's entirely up to you guys. Okay, now we're trying to solve for y. And somebody had a good idea last problem, but I told you to hold on to that. Who was I talking to?
Me.
All right, Catherine, what did you say?
That it would be the natural log of y.
Yeah, perfect. So if you take, in this scenario, if you take the natural log of both sides, you can just, from outer space, send in natural log. It appears out of nowhere. The only thing is that if it appears out of nowhere on the left, you got to make it appear out of nowhere on the right. So you can toss it in anytime you want. Just do it on both sides. So now I've natural logged the left and I've natural logged the right. But what happens over here now? When you do natural log of e to the stuff, what do you get?
Stuff.
You get the stuff. So this zaps the e. And now we just have y equals, more specifically, we have -y equals, if I can copy symbols, -y equals natural log of -x cubed plus 3x squared minus 1. Last step, pretty simple, divide both sides by -1. And your particular solution is y is equal to negative symbol, natural log, -x to the 3rd plus 3x squared minus 1. Done. Questions, comments, thoughts? There's got to be a fair amount of questions. This is a lot of stuff. Anything?
Where did the ln come in? Like, why did you do that?
It came in from outer space, basically. We just tossed it in. So anytime you're going to see here that there's only like 3 different ending situations to a problem. One of them is e to the y. Let me pull up. Yeah, it's in here somewhere. Let me share this with you. Hold on. Let's see. Hang on, give me 1 second. I gotta find it. Okay, give me 1 second here to find the page.
Even if we had used the natural log or logarithm rule, in that case, it would have made sense that y equals to the natural log of, or the logarithm of that stuff to the that specific base.
Say that one more time.
I mean, even the regular definition of logarithm or natural log would have made sense in that case, you know.
Yeah, you can use that. It's just natural log of e is going to take you right to the exponent.
Yeah, there's no base. Yeah.
Let's see, where is, I have something for notes here. Where are those notes? No. Give me 1 second here. I've got a good summary of this. I just gotta find it. There we go. Exam notes. Okay, so check this out. You will have access to all of this before you take your exam. Let's focus on the right side. This is a differential equations summary. So it says, I have like 10 pages of notes for you guys to take with you to study with. So for differential equations, split the variables, integrate both sides, plug in the point to find C, solve for the letter you're asked. That's usually Y. All right, now copy these ending scenarios down. So when you look down here, it says ending scenarios. This is after you find, after you have found C and all that, and you're just trying to solve for Y. So check this out. This one over here, this was the first one that we just did. Flip both fractions. I'm trying to solve for Y, right? So in this case, flip the left, flip the right, solve for Y. Cool. Here's the one we're doing right now, top right corner. E to the stuff is equal to 4 and your Y is locked in. So it's all about solving it for Y. So in this one down here, Y is on the bottom. How do we solve it? Flip, flip. Cool. All right, this one, Y is stuck upstairs with E. How do we undo that one? Natural log both sides. Natural log of E to the stuff's the stuff. Natural log the other side stays. Solve for Y. Okay, here's another one we haven't come across yet. How about if your Y is stuck inside of natural log? You can change it to log base E and use logarithm formula. I think that's what you might have just been saying a second ago, Syed, right?
Yeah, it should be e to the 3 times x and y negative 1, and we flip the 1 to the other side.
Yeah, so you can go ahead and solve it that way if you have it inside of the natural log. down here in the bottom right corner, there's another version involving a square root. That's not too hard though, right? Square both sides to unlock the y. So if I were you guys, I would copy those down. Those are the major, oh, here's a fifth one down there too. That's just common sense. Take the square root of both sides. These four up here though, I would take notes that says ending scenarios for differential equations. And then those are all the different ways that when you're trying to finish this problem off, that you're able to solve for y. So let's take a second and copy those down. And then when you have those in your notes to glance at, should make things a lot easier.
Mr. Baker, is it feasible that you take a picture of this and post it on Remind? That way, like, we wouldn't miss like anything from it.
Yeah, I can just post all of this on Canvas, truthfully. There's 7 pages of notes just like this. So we can flip through them in a second. You'll see how much of this year you already know. So we're getting there now, guys. You're into the final bits of this now. So if you take a look, when I scroll here, can you see me turning pages here?
Yes.
All right, so take a look at this. If we go back to, where's the page numbers? Hold on. Whatever, here's limits. L'Hopital's rule, I need to teach you that a little more. Continuity, we know continuity. Squeeze theorem, yeah, I got to teach you that a little bit too. So that page wasn't a good example. This page, we definitely know. Absolute, min, and max. There's the write up for that. Particle speeding up or slowing down, we know that. Words for rate of change. Position, velocity, acceleration. Here's your MVT stuff. Here's your integration stuff. This whole page you know how to do. Here's the integration rule. Here's FTC. If you have the graph of f, the integral of f means area. If you have the graph of f, f prime means slope. We've done all of that. Here's all your different integration techniques. You know all of these. Trig derivatives, U substitution, you know all of those. Here's a list of all your chain rules. We've known those forever. Trig derivative, the composite, the radicals, product rule, quotient rule. You know this over here. G equals integral f, G primes f, G double primes f prime. Here's all your trig derivatives, natural log derivative. I got to teach you this little piece right here. Probably, that's no big deal. Look at all the other stuff you know. Graphs, Riemann sums, analyzing the derivative graph. You guys have learned a ton of math this year. So if you look at all this, you've been taught and you know just about all of this. Implicit differentiation and related rates, no problem. And now, right now, we're hammering out differential equations. And that's really all the notes I had for you guys that I made for last year. There's a little more that I got to teach you, but we're like 80% of the way there now. So I can post all of this on Canvas though, so you have something to look at. Okay. All right, other questions, comments, thoughts? What do we think? Okay, so this just takes more practice, which is what we will be doing tomorrow. So that's it, guys. 45 minutes of differential equations is plenty for your Wednesday evening. Give me 1 second to scribble some names down for attendance, and you will be out of here tomorrow. Just make sure you come. It takes practice to do this. So I'll have more of these for you tomorrow to do on your own, and we'll go from there. All right, so we got Albert, Angie, Anna, Bennett, Campbell, Caroline, Catherine, Grace, Helen, Jameson, Jason, JD, Josie, Nancy, Phoebe, Sarah, Sarah. Syed. Taylor. Well, okay, guys, I got it. Have a good night. I will see you guys tomorrow.
Thank you.
Would you mind showing the ending scenarios one more time, just so I can copy down
Yep.
the main thing? Thank you.
Do we have any homework that we should do? before
Tonight, no. Over the weekend, yes.
Okay, thanks. Have a nice day.
You too. Okay, there we go.
Okay, I think that's basically it. I have it all down.
Cool. See you tomorrow.
Thank you, Mr. Baker. Have a good evening.
You too. See ya.